Hello everyone, so today I'll be doing pseudocode as I have gotten multiple requests to do that as this is a new addition to the study design for methods. So without a further ado, let us get started. So what exactly is pseudocode? Well, pseudocode is a simplified and informal high-level description of a computer program. Now what that means is, before let's say you want to go somewhere, you have to plan your journey, right? That entire planning stage is going to be considered as your pseudocode. So let's say that you have to go to some sort of a market near your house. So the first thing you'll do is, go out of the house or walk there or take a bus, take a train or whatever you want to do. So whatever you plan, that's going to be considered as a pseudocode. But pseudocode is mainly referring to programming stuff. So yeah, but this is just like an example that I gave to make it a bit more relatable, I guess. And one more example I can give for all the year 12 math people out there. Well, let's say that you have to find the stationary point of a random polynomial function. What will be our first step? First step will be differentiate the polynomial function. Second step would be set that differentiated function equals to 0. Third step would be solve for x from the differentiated function, and then put that x back into the original function and get the y coordinate. That's step 4. And then step 5, finally you get your output that your stationary point is going to be your x coordinate and y coordinate parentheses. So all of that steps that we took to get the final approach, final answer is known as pseudocode. But yeah, this is just for maths, but for programming it's specifically called pseudocode. Alright, so it is used for planning and understand the logic and approach, as I already mentioned that this is probably why they have added this into the unit, into the subject, so that people can develop their logic and polish their logical skills and get a bit more rational about how they're going to approach to a solution, because this is a very important skills, whether it be maths, computers, or just life in general. So it's quite an important skill. And last, programmers often make a pseudocode before they start coding their real problem. Well, I don't know if anybody of you guys watching has done any programming before, but when you program, you must have a plan or an approach to get to the final output that you want. So what you do is make like a dummy code where you have while loops and stuff, but they are not quite coded properly yet, not executable stage, but you still have that rough plan ready to go, and that's pseudocode. So that's the relevance of learning pseudocode and what that is. So let us continue to learn from the example of pseudocode and see what we get. Alright, so pseudocode, well, for VCE purposes in your math methods exam, you will have input where you will have an input section where you will have a lot of variables, or however many variables that are used in the function. They will be defined, like let's say that in this case we have f of x, which is a function of x, a is the lower limit of integration, and stuff like that. So they will make clear what each variable represents, so that that will avoid confusion. So this is very important. Now the next step is that they define a function over here, and so for example our function is called rectangle integration, and they have defined it over here like the highlighted box that I just had. And this whole stuff is going to be what the function is going to do. And what are they going to mainly ask you is that they want you to run this function with your mathematical skills and get to the final answer. Now, I haven't seen pseudocode in exam 1, so if I'm blind, just write in the comments that, well, I have missed something. But I've only seen that in MCQ for exam 2. So yeah, so what they do is, well, they give you something like this, and then they expect you to work something out based on this code, and then just select the answer. So it's pretty standard questions. However, this will take you a lot of time to do that in the real exam. So what I recommend you to do is skip the pseudocode questions till the end, unless they are going to be in the extended response as well. But if they are in MCQs, and if you think you cannot do them quick enough, just leave them till the end. It's better to lose 3 marks than lose marks in the wording problem, which you can probably do. So plan accordingly. Alright, so variable, use, and input. Okay, so I'm just going to break this entire pseudocode down into pieces and explain as best as I can to make it clear as to what each function and what each section of the pseudocode do. So variables used, as I mentioned already, that this will describe what each variable represent. Now say, to relate back again, now say that you have like a wording problem where you have those typical box questions where you have a sheet of something and then you cut out x by x squares from each corner, make it into a like a open box, and then you have to calculate maximum minimum volume and stuff like that. So it's the same over here. Now we know what x represents in that scenario, right? X is going to be the length or the width, which are both going to be the same for the rectangle, right? So same way, they have defined what a, b, and f of x mean on this section, and you must pay close attention to it so that you don't mess up from the get-go, because this section is very important and you need to understand what each variable does, and I hope that they make it simple enough for all of the students to understand. Alright, now defining function. Now okay, so defining function is done quite similarly as we normally do in our CAS calculator. Now for example, this part over here is the name of the function, and this part over here is called argument or parameters. Now to relate back again, I can give you an example that you use in your daily methods life. So what you can say is, whenever you define a function in CAS, it will give you define, and then you say f of x equals to supposing x squared, right? So this part over here is also technically a function, except this is going to be a function name and this is going to be your parameter. Now what is parameter exactly? Parameter is a variable that you are going to be using in that function. So it's basically like saying, oh, you have a function f, but it's going to have the variable or the parameter x in it, and that will vary the value of the function, right? So our function name is going to be f, and our parameter for this case is going to be x. Now same way, on a bigger scale, you can think of it the same way. So this entire thing as mentioned is going to be the name, and this function is going to be using this parameters over here. So it's nothing different, just a bit bigger than what you expect to do in your normal methods class. Alright, so I hope that was clear. Now let's move on to function itself. Now we had a look already at this line over here in the previous slide, and the next thing that needs to be done, of course, if you define a function, you have to assign it some task, right? That's just obvious. So whenever you define a function, there will be a task to it. So what all of this part does is that this is the task of the function. So this is going to be the define function command. So you made a function, and what is this function going to do? Is going to do everything over here till end function, because once you say end function, that means that function job is finished. That's it, done. And now we move on to the next function or whatever. Okay, so keep that in mind. Now let's do loops. Now based on your textbook and also your exams, your practice exams, I have noticed that the most common types of loop is going to be while loop and if loop. So I'll explain both of them. Now I have forgotten one line, so Alright, so this is the line that I forgot. Now I'll explain why I added these lines. So let's start off with while loop. Now, so we have clarified. Now of course the function, Now of course if I were to scroll back, the function is going to read this as our first line, second line, third line, so on and so forth, all the way to the bottom. Okay, just keep that order in mind. Now keeping that order in mind, our function has done all of this first line already. So now it's moving on to second line. So consider that scenario. Now let's continue. So in the second line, we have that sum is equals to 0. Now this arrow is basically just meaning equal to, nothing different. So sum is going to be equals to 0. Okay, that's what the second line is saying. The third line is saying that I is going to be equals to 0. I'll explain what everything is. Okay, now after that line, we are entering into a while loop. Now okay, so while I is less than n. Now what is n? We already have it, that n is going to be the number of rectangles that we use to calculate or approximate the area under the function, which is what this function task is to do. You know how we learned that area under the graph is going to be thin slices of rectangle added together, infinitely thin slices. So this is just saying that, for n number of rectangles under the area of the curve, how well is it going to approximate the area or calculate the area based on that. So that's what the function job to do. Alright, so based on that, now we know what n is. So n is going to be the number of rectangles we choose to have to calculate the approximate area under the graph. Alright, so let's say our n is going to be 3. So while I is going to be less than 3, just keep doing this line. So 1, 2, 3, just keep doing these 3 lines because it's a while loop. So till I meets this condition over here, it will keep looping this function over here, these three tasks under the while loop. Now this will answer why we have, why we have these two lines over here. Now as you can see, line number 1 under while loop is just stating that x is going to be a variable that is going to be calculated by this formula over here, which is relying on a, h, and I. Of course, that's fine, it's just a formula like we have for, a family of functions, or express x in terms of a, b, c, or k, or whatever. That's the same thing but in pseudocode. Okay, nothing different. Now we look at the second line in the while function. Now this line will answer exactly why these two lines over here exist. Okay, so it says sum equals to sum plus f of x. Now let's say that I run this function over here, I run this command. It's going to read sum equals to 0 first, and then it's going to read I equals to 0, and then it's going to go under this loop, right? Okay, so our starting value for the sum is going to be what? 0, because it got that value by reading from here, right? Okay, now that made sense. So this is going to be 0 in when I equals to 0, sum is also going to be equals to 0 because we have just entered the loop. Now once you calculate sum, let's say that if you substitute in I equals to 0 and then calculate all of this, you'll get sum equals to some random number, let's say 4. Let's say you get sum equals to 4 when you substitute and calculate sum for the first time. Now what will happen second time? So once you have calculated sum, it will move on to this line over here, of course. Before it repeats the second time, we have to consider this line as well. Now this line is just going to be an increment statement. Again, it's the same thing as sum. So it read this line over here before coming into the while loop. And it knows, this command knows, this function knows that I is going to be equals to 0. So it's going to substitute I equals to 0 over here. And now, do we finish over here? No, because currently our I is just equals to 0. We want it so that while I is less than 3. So how many times do we have to repeat this while loop? Well, for I equals to 0, we already done that. For I equals to 1, we have to do it now. And for I equals to 2. Can we do I equals to 3? No, we cannot, because it says less than. It doesn't say less than or equal to. Alright, now, let's say that we are finding values for I equals to 1 now. What will happen? So after reading these three lines, after doing these three lines, this function will again go back to this line over here, the very first line relating to x. And again, now I is going to be what? Now I is going to be 1, because we already calculated I equals to 0, so now I is going to be 1. Okay, so after it calculated x that way, now it will go back to the sum. Now my question is, this over here, what would be the value of this sum over here? Would it be 0, or what would it be? Well, it's going to be 4. The reason being that we are still inside this while loop. We haven't left the while loop yet. And these lines are already read, so these lines are now irrelevant. Because, well, they're already read, we are in the while loop, so we do not consider this line on the top here. Okay? Now, we will use sum equals to 4, that we assume to be for when I equals to 0, to calculate sum for the next part, and for the next part, and for the next part, and so on and so forth. Okay? So that's how while loop works. And now this statement over here, well, I started from 0, now I is going to be 1, and next time I is going to be 2, and next time I is going to be 3, so on and so forth. So both of this can be classified as an increment statement, but you don't have to worry about all of that. But this is just me explaining how while loop actually works, because it's very important you understand what while loop actually do, or else it's going to be quite doomed in the exam, right? Okay, so that's entire while loop. Now let's look at if loop. Okay, now say that our a equals to 1 and b equals to 2. If a is greater than b, return true, and if or else, return false. This is literally just like reading English. If a is greater than b, return true, meaning it will give you true. And if a is less than b, well, it's going to give you false. So what would our output be if I run this command? Would it be true or would it be false? Well, obviously it's going to be true, right? Because a is indeed greater than b, 1 is greater than 2, said me. No, just kidding. It is going to be false. So that's your if loop already done and dusted. So I hope that all of this made sense, because now, using all of this knowledge that we just have, we are going to calculate stuff using this exact same code that we have been breaking down. Now I'm going to say that f of x equals to x squared, a equals to 1, b equals to 4, and n equals to 3. And what do we have to calculate? Where does it say that in the function? Right here. We have to return h times the sum. Okay, let's do this now. So we have all of the input already over here, which is saying what a, b, and n and f of x is. So that's all fine. A is the lower limit of the integral, b is the upper limit, n is the number of rectangles, and f of x is a function of x. So that's all clear. And now let's move on to the next line, which is going to be this. So they have just defined the function over here with this parameters over here. So that's also fine. And this function is named rectangle integration. Okay, so that's also fine. Now let's look at the next line. So h is equals to b minus a on n. Now my question is, will h value change? Even if we go in the while loop, or we don't go in the while loop, will the h value change at all? No, it wouldn't, because it's just in one line. There's no relation whatsoever. It's not inside the while loop. It's just by itself, where they're just saying that h is going to be equals to b minus a on n in terms of a, b, and n. So let's calculate that. So h is going to be equals to b minus a, so 4 minus 1 on 3. So therefore h is equals to 1. Now since this is not going to change at all, what I'm going to do is I'm going to just write it down over here, just so that I can remember. And I'm going to erase this out for more space, of course. Alright, so now this line is all done. Now let's look at this line over here. Sum is equals to 0. So we have no task to do over here. They have just mentioned that sum initially is going to be equals to 0. Alright, now let's look at this line over here. Same thing. They have just said that I initially is going to be equals to 0. We have to do no calculation whatsoever. So that's all fine. Now we are entering into while loop. While I is less than n. Now what is our n? 3. So how many times will this loop happen? It will happen for I equals to 0. Then it will happen for I equals to 1. Then it will happen for I equals to 2. So we have to run this while loop how many times? Correct, 3 times. Okay, now let's look at what this while loop is saying. So let's look at this line over here. So x is equals to a plus h times I plus 0.5 in parentheses. Okay, so let's calculate x for when I is equals to 0. So x is equals to, I'm just going to substitute values in. So a is going to be 1, h is 1, times it by I, which is going to be 0. So 1 plus 1 times 0.5, which is just going to be equals to 2. Now let's look at the second line over here. So sum is equals to sum plus f of x. Now what did we discuss about sum earlier on over here when I was explaining while loop? When I is equals to 0, meaning that we have just read all of this line, and now we just came in the while loop. So what would our initial sum value be? So initial sum value over here would be 0. So sum equals to 0 plus f of x. Now what is this x? Oh, sorry, this is going to be 1. I just realized, bruh. Okay, what is our x? Well, our x is going to be from what we calculated in line 1. What we calculated over this line. So it's going to be 1. So we have to basically find out f of 1, which is just going to be equals to 0 plus 1. So it's just going to be 1. Okay, now let's look at when I equals to 1, because this is what the line is saying. So it's just incrementing I from 0 to 1. Okay, so let's look at I equals to 1 now. Now do we go out of while loop just yet? No, we don't, because we are not done yet. We have to make sure that I is less than 3. Look at I equals to 1 now. So let's calculate x for I equals to 1. So that would be x equals to 1 plus 1 times by 1 plus 0.5. So that is going to be 2 times 1.5, which is going to be equals to 3. And now sum is equals to sum plus f of x. So what is our sum going to be now? Would it be 0 or would it be the value from here? Yes, it will be the value from here. The reason being that we are in the while loop. We do not go outside the while loop until this condition is met. So we forget about this, we forget about everything below it, we just look in the while loop, okay? So sum is equals to 1 plus f of 3, because this 3 comes from here, okay? So f of 3 is going to be 9, because our f is equals to x squared. So our sum is equals to 10. Alright, now let's calculate I equals to 2. So again, we go into the first line under while loop. So x is equals to 1 plus 1 times 2.5. So 2 times 2.5 is going to be equals to 5. And our sum is equals to sum, which is going to be what? 10 plus f of 5, which is going to be equals to, so that would mean our final sum is going to be 35. Okay? Alright, are we done over here? No, we are not, because we still have to look at this very last line over here. We are done with the while loop because we have met the condition that if I have set I equals to 3, that's it. It's not true. So now we step out, because I equals to 2 is the maximum value of I that can be obtained to satisfy this condition over here. So we step out of the while loop now. Let's read what's underneath that. So it says end while loop. So while loop is all finished. Our task for while loop is done. And the next line it says that we have to return h times the sum. So what is our h? It's going to be 1 and times it by the sum, which is going to be 35. So our answer is going to be 35. And that's how you tackle these sort of pseudocode questions. Alright, so that's it for this video. I hope you found this helpful. Alright, I'll see you in the next video. Bye bye.